AI, machine learning, deep learning. Okay, let's be honest, you hear these terms thrown around all the time, right? And a lot of the time, they're used like they're the exact same thing. But are they? Well, not really. So we're going to spend the next few minutes breaking down what each one actually is, and more importantly, how they all fit together. Let's dive in.
So this is the big question, isn't it? And it's a really good one, because if you can get your head around this, you'll understand so much more about the technology that is literally changing our world as we speak. So let's start at the very top, with the biggest picture of all. You know, the best way to think about all this is to imagine we're looking at a huge map, a map of a technological universe. We're going to start with the widest possible view, looking at the entire galaxy that holds everything else inside it. And that galaxy is artificial intelligence. So, at its absolute core, AI is the big, overarching concept. It's the whole field. The ultimate goal here is to build machines that can think, reason, learn, and solve problems. Basically, to do things that we normally associate with human intelligence. Think of it as the big umbrella that covers everything else we're about to talk about. And this really gets to the heart of what AI is trying to achieve. It's not just about crunching numbers faster, it's about recreating these incredible abilities we have. Things we do almost without thinking, right? Like understanding what someone is saying, recognizing a face in a crowd, or figuring out how to solve a puzzle you've never seen before. AI is the grand ambition to build all of that into a machine.
Okay, so let's zoom in. We're moving from that vast AI universe to a really specific and incredibly powerful star system inside of it. And this is where machine learning comes into play. It's not something separate from AI. It's a very specific and very effective way of achieving AI.
And this right here illustrates the game-changing difference. A basic old-school AI might be like a chess program where a developer literally wrote out all the rules. If this, then that. It can be smart, sure, but it's totally rigid. A machine learning system, on the other hand, well, you don't give it the rules. You just give it a ton of data, like thousands of chess games, and it figures out the winning strategies all by itself. It actually learns and gets better over time.
And that leads us right to the core idea of machine learning. It is all about learning from data. Instead of a programmer sitting there trying to hand code rules for every single possible situation, they build a model that can look at the data, find the hidden patterns, and then make its own predictions. It's a total shift in thinking.
Let's make this super concrete, because this example is perfect. Imagine you want to teach a machine to know the difference between a cat and a dog. The old way, you might try to write rules, like if it has pointy ears and whiskers, it's a cat. But what about cats with floppy ears? It just breaks. With machine learning, you just show it thousands of photos labeled cat and thousands more labeled dog. The model just churns through all that data, figures out the patterns on its own, the things that make a cat, and eventually it gets so good it can look at a photo it's never seen before and say, yep, that's a dog. It's learning from raw experience.
So if machine learning is that powerful star system, where do we go from there? We go deeper. We zoom in on the supercharged engine that's powering the most advanced ships in that system. This is deep learning. It's a specialized, cutting-edge type of machine learning that's behind pretty much every major AI breakthrough you hear about today.
The magic words here are artificial neural networks with many layers. That's what makes deep learning deep. It's this layered structure that lets the machine learn in a much more sophisticated, much more complex way than traditional machine learning ever could.
And this is where it gets really, really cool. The whole structure of these neural networks, it's loosely inspired by the web of interconnected neurons in our own brains. It's like we're trying to build a system that can process information in a similar way that we do, allowing it to learn in a much more intuitive, layered fashion. So how does this layered thing actually work? Well, imagine a deep learning model looking at a picture of a face. The very first layer might just see really simple stuff, like edges or patches of color. The next layer up combines those edges to recognize basic shapes like an eye or a nose. And then the deepest layers put all those pieces together to understand a complex concept, like recognizing your specific face. It's building understanding piece by piece, from simple to complex. And look, this isn't just some abstract theory. This is the tech we use every single day. The intelligence in a self-driving car sensing a pedestrian, the way ChatGPT can write a poem, your phone unlocking with your face, Siri understanding your question, even Netflix knowing exactly what movie you want to watch next. That is all powered by deep learning. It is truly the engine of modern AI.
Okay,
We have zoomed all the way into the nitty-gritty. So now let's pull back. Let's zoom all the way out and look at the complete picture so we can see how all these pieces fit together perfectly.
So let's rebuild it. At the very highest level, you have the entire universe, the whole concept of making machines intelligent, and that is artificial intelligence.
Now, nested inside that universe is the powerful approach where machines don't just follow rules, they learn from data. And that, of course, is machine learning.
And then, right at the core, the engine driving today's biggest breakthroughs is that special technique that uses those brain-inspired neural networks, and that is deep learning.
And this brings us to this simple, crystal clear hierarchy. All deep learning is a type of machine learning, and all machine learning is a type of artificial intelligence. They aren't three different things competing with each other, they are nested layers of capability. Each one is a more specialized version of the one before it.
But so what? Why does knowing this even matter? Well, it's not just about winning an argument with your friend. Understanding this hierarchy is actually key to understanding where technology is going.
Here is the big takeaway. This progression, from the broad dream of AI, to the data-driven power of ML, and down to the complex, brain-like models of DL, it's like a ladder of increasing power and autonomy. With each step down into these more specialized fields, the machines can handle way more complex problems, with way less human handholding, and with results that are, frankly, astonishing.
And that leaves us with one final mind-bending question. We've seen these systems learn to see, to write, to create art, to drive cars. As these learning systems get deeper and more autonomous, what's the next frontier? What will a machine be able to learn next? That is the open question, and we are all going to be here to watch it unfold. Thanks so much for joining me for this explainer.